everyone, welcome back to the sample solutions for BSDS paper 2024. We are nearly towards the end of the series. There are 32 questions in total. We are at question 31 now. Question 31 is based on vector algebra. So the definition of the unit vectors as well as the orthogonal projections are given here, right? So let us read the question. Let A and B be two non-zero vectors in three dimensions. The orthogonal projections of B onto A is C equal to E dot B product E, where E is the unit vector. Alright, now there are three conditions given. We have to check which of them are true. Alright, so there is nothing extra given here, just the definition of orthogonal projection is given. Now we have to just check if these three options are true. Now these are very common options and we have found them in subparts of different solutions in books. Alright, so I have taken the three solutions from separate sums and I have tried to stitch them together. I'll explain each of the parts to you in this video. Alright, so the first part, we have three options to check here. So I'll check option A first. Now what does option A imply? Option A says if B minus C is non-zero, then modulus of A dot B, the dot product, would be equal to unit vector A into unit vector B. Alright, now what is given? Given that C is E dot B dot E, where E is the unit vector in the direction of A, we know that C is the orthogonal projection of B onto A. Alright, so C is the orthogonal projection of B into onto A. Okay, so B minus C will be, when will B minus C be non-zero? Here it is already given that B minus C is non-zero, so the value is known. But when will it be non-zero? It will be non-zero when B is not parallel to A, not parallel or anti-parallel, right? I hope you understood anti-parallel. Parallel means they're moving in the same direction with the width between the two lines or two planes being constant. Anti-parallel means they're moving in opposite directions, yet the difference in distances or width between the two planes or lines is constant. Alright, so this is how we calculate it. B minus C will be non-zero if B is not parallel or anti-parallel to A. That means if B has a component orthogonal to A. Alright, now modulus of A dot B into unit vector A into unit vector B is a true statement if and only if A and B are parallel or anti-parallel, right? If they are parallel or anti-parallel, this will hold. That is when B lies on the line which is defined by A in the direction or opposite to the direction. That is the definition of parallel and anti-parallel, right? So therefore if B minus C is non-zero, implies B has a component orthogonal to A, meaning B is not parallel or anti-parallel to A. Alright, so by B minus C non-zero, we mean that B will have a component which is orthogonal to A, so it cannot be parallel. If it cannot be parallel, then that statement will not hold. So option A is false. Okay, the first statement is false. Alright, so this is gone. Now what remains? We have to check option B. This does not hold, so option B is this one. So for option B, what do we have? For option B, we have if B minus C equals to 0. That means B is entirely in the direction of A. So in the last option, we had B minus C non-zero. That means B minus C had an orthogonal component which was towards the direction of A. Here, there is no such orthogonal component. B minus C 0 means B is entirely in the direction of A because the projection C fully captures B along the direction of A. Therefore, B and A are parallel or anti-parallel. Okay, so two different cases. I hope option B is clearer when you understand option A. Now if B and A are parallel or anti-parallel, then by definition we have of the dot product we have equals, right? But the question says less than, so clearly this is not true, right? Strict inequality does not hold. Alright, so this is false. Okay, so the conditions are just reversed. If B minus C is non-zero, then we could have given the result from option B to be true, and if B minus C is 0, then we could have used the result from option A. So they have switched the options, that is why both options are false. Now coming to option C. What does the Cauchy-Schwarz inequality state? The Cauchy-Schwarz inequality states that for any two vectors u and v in an inner product space, this is just the theorem written down, the absolute value of the inner product is less or equals to the product of their magnitudes. Alright, so u minus v modulus is less than equal to unit vector u into unit vector, sorry, length u into length v. Okay, now consider the vector b minus c. If length of b minus c greater than 0, it implies the norm. Okay, the norm magnitude is non-negative. So if I write b minus c as b minus e into b, because that is the definition given here, right? And the length of a unit vector is also to be put here in the value of e. So b minus c, the norm would be b minus e dot b into e, right, according to the definition that was given. This is the norm representing the distance between B and its projection onto A, which is C. Alright. Therefore, B minus C represents the length of the vector connecting B to its projection onto A. So vector B, projection onto vector A, and norm of B minus C will indicate that distance. Alright. Now using the Cauchy-Schwarz inequality, if as E is the unit vector, we have E dot B is less than norm B or unit vector B, multiplying both sides by E because it's 1, right? It was the unit vector. We get E dot B modulus less than equal to B in norm. Alright. Now once you have that, then this is equivalent to saying B minus C norm B greater than equal to 0. Indeed, the inequality is equivalent to Cauchy-Schwarz inequality. So what happened? What did we do here? We took the Cauchy-Schwarz inequality and then we showed how if we take B minus C to be greater than equals to 0, we are able to satisfy the conditions of Cauchy-Schwarz inequality. Alright. So this means that if we take option C to be correct, then what is the option first? Let us check that. The option says that they are equivalent, right? Equivalent does not mean that we can prove Cauchy-Schwarz inequality from here. Equivalent means if norm of B minus C greater than 0, that means this and the Cauchy-Schwarz inequality are consistent. Alright, that means whatever is said in the Cauchy-Schwarz inequality is being obeyed and followed by norm B minus C greater than 0. So that already was proven in the text that I showed you for option C. Okay, I just explained the steps to you, and if you have not understood the important steps, do note these down and then read them slowly. Go to the definition of Cauchy-Schwarz inequality, match the definitions as well as the workings, you will understand it. Alright, if you have any problems relating to this chapter, do let us know in the contact number given below in the comment section, and I'll see you all in the last question. Bye.